Hi everyone, welcome back. So this is a short video for Practical 3, clustering of crime points for my Introduction to Spatial Data and Using R as a GIS course. So I'm going to go through Practical 3 in the workbook here. Do check out the links below for the other videos in the series and to the material itself. Cool, so let's go straight into our studio. So this is the script that I've used from Practical 2. Best practice would be to create a new script. So we can create a new script and call this Practical 3. And we could also potentially save this in a new working directory. So I'm going to follow the pattern that I've got already here and call this intro r prac 3. You can probably get away with using the same working directory. But it depends how you want to structure your stuff. If you do make a new working directory, the key thing is to make sure we actually change it in our studio. So we've got our Practical 2 from earlier, go back to GIS, intro our Practical 3, click on the little cog, set as working directory. So all the files for this practical are going to be stored in here. And we can also close this script because we don't need it. Cool. So we are going to have a look at some point data and look at how we look at clustering. So we're going to read in some point data and look at reprojection as well, because that's a key bit for this sort of data. So we're going to read in some data. So this is some crime data, and this is available from Merseyside Police. So this is from, so it's a little bit old now, April 2020. You can get more up-to-date data if you go to police.uk and then look for data on there. So we've read it in as a CSV file. Let's clear the environment just so we can see what we're going on, because we've got a whole bunch of stuff in here. So if you click this broom icon, that will get rid of everything. So we're working with a kind of clean slate. So let's read the data in again. We have our crimes data. And if we want to have a look at the first 6 rows, we can use the head tool. And here we go. So the first 6 rows. So we've got crime ID, which is present for some of them, month, reported by, falls within, longitude and latitude, location, LSOA code, LSOA name, and crime type. And then last outcome category. So we've not got complete data for all fields here, but from our point of view, longitude and latitude is really important. So we have the location. At the moment, this is just a table. R doesn't know this is spatial data. As far as R is concerned, longitude and latitude, they're just a number. So if we have a look at class, it will tell us, so we're saying what is the type of data that crimes is, and it's a data frame. And I think at str crimes will show us the data type for each column. Yeah, there we go. So data frame, 13,000 rows, observations, 12 variables, 12 columns. Crime ID, month, Longitude and latitude are just numbers. So R has no concept that these are coordinates. We have to say to R that this is a set of coordinates. So we're going to create a new variable called crimes SF. So crimes simple features. SF is just a name that we're using to show that it's spatial data. And we've got this function st as SF, and this will create our spatial data. So we're saying, okay, we'll use the crimes data, and we've got to say what are the coordinates. So we do coordinates are, and then we've got to give it a list. So we use C for list like we did before, open brackets, single quotes, and then longitude, ITUDE, close quotes, comma, and then latitude. The order is really important here, so you have to make sure you get that order correct. And then finally, we need to say what coordinate reference system it's in. So if you're not sure what coordinate reference system is, go and have a look at some of the links in below or in the workbook. We need to say that the CRS is 4326. So we're saying that these data are using latitude, longitude. And then if we run that, it will create crimes SF for us. And we can use head to have a look at it. And there we go. This looks much the same, but we have our new header information saying it's a simple feature. It's points, bounding box, and then what the coordinate reference system is. So WGS 84 here. And we also have our geometry column. So this is now our knows its spatial data. So it's given it what it calls a geometry column. So where it is, and it's saying it's a point, and these are the coordinates. And we can preview it using QTM as well. So that should appear, and there we go. So this is the outline of Merseyside. Just for context, Merseyside is a kind of area around Liverpool. So we have Liverpool City, which is kind of this chunk here, and then we have various bits outside Liverpool. So St Helens is one of those, the Wirral is another one, and there's various other places as well. And this is useful because this layout shows us the data so we can be confident that it's read it in properly and it looks about right. So at the moment, this is in latitude, longitude. If we want to work with it with some LSOA data, our LSOA data is in British National Grid, so a different coordinate system. So what we can do is if we need to reproject this. So we're going to turn it from latitude, longitude to British National Grid. So that's what this bit of code does. So we're going to create a new thing called crimes SFBNG, crimes simple features British National Grid, and we're using this function stTransform. So this will take crimes SF and it will have a look at it and say, okay, this in latitude, longitude, reproject it to this coordinate system. So 27700 is the numbers for British National Grid. So if we run that, it will reproject it for us. And then if we have a look at head, crimes SF, the geometry and so on is the same. This is still in latitude, longitude. I need to put crimes SF BNG because that's the one we just created. And you'll notice the coordinates have changed. So these are now 6 digits instead of 3. Well, they're 6 digits instead of 2 before the decimal point. And if we look at the header, it also says SGTB 36, British National Grid. And we can also still do QTM as before. Oops. Yeah, and the data look more or less the same. It is a slightly different shape, and this is because this is how the shapes look slightly different in the different coordinate systems. So for, this area is relatively small, there's practically no different. If you looked at the whole of Great Britain, it would look slightly different, it looks a slightly different shape. And this is to do with the projection that it's working in. And we can create a map of these using TM shape, much the same as we did before. It's worth pointing out TM shape is the same, but we use TM dots instead of TM polygon because we're working with point data rather than polygons. Why it's called TM dots and not TM point, I don't know, but it is. So we say what size we want it, what shape. So shape is a list of categories, and this kind of square diamond shape is number 19. Color, whatever color you like in there, and then alpha is the transparency. So we've made it kind of semi-transparent. This is nice for this sort because there's lots and lots of data, so we can see where it's darker, there's many, many points, where it's lighter, there are fewer points. One other thing of note is we can look at the type of crime as well. So there's this handy function called table. So table will give us a table of whatever column we specify. So here we're going to say crime type, and it'll tell us how many entries there are for each crime type. So you can see we've got nearly 5,000 for antisocial behavior, 75 bicycle theft, nearly 500 burglary, and so on. So, this is fine. We can overlay the data on our LSOA data. So before that, we need to read it in because I tidied up all the variables and our LSOA data is gone. So we could go back to the second practical, and we will have to change the working directory again. So this is one of the disadvantages of having these kind of multiple working directories. So I've just run through the process of reading in the data and merging it. So this is what you should have already. If you're not sure, go back. We need the population data because we're going to be using it later. So if I switch back to our practical 3 script, we can plot the crime data, which we've done already. So that's that bit, and that's not changed. It's, red rather than dark red. But we can then put the LSOA data on top. So you see we've got this plus here. This links it all together. So this is all one chunk of code. So R will load it all together. And if we go back to the plots window, so we've got our red dots, which are not changed, and then we've got our gray outline. So these are the LSOAs. This, we can't see much detail because the way R works is it shows the first data set in its entirety first. So if we swap the order around, so if we take the LSOA and plot that first, and then plot the crime data, it will show us the LSOA data first, and then the crime data. So we should zoom in onto the Liverpool area. There we go. So you can see we've got the Liverpool outline. It's not as obvious as it might be. One cheat way of doing it is to plot the LSOA data again on top of this. So it should be a little bit more obvious. We'll see what it looks like. Yeah, you can kind of see the gray outline a bit more. If we wanted to, we could fiddle about with the colors and make it a bit clearer, but we get the idea. However, this doesn't really tell us much about the data. We can see where there are more points and less points, but we can actually link these two. So we can do what's called a spatial join. And the specific type of one we're going to do is something called a point in polygon. So the points are our crimes. I'm going to count how many crimes there are in each polygon. And that's what this one does here. So our function is stjoin, join the LSOAs and the crimes data. And we're creating this new thing called LSOA crimes. If we have a look at that, we've got a big long list. So what this will do is we'll list every LSOA and every crime. So it's ended up being quite a long list. So yeah, we've got 5,000 observations. So it'll keep the LSOAs and repeat every LSOA for each crime. The ones that are outside the LSOAs, it'll just ignore. But, this in itself is a middle step because we can't map this as such because we've got each LSOA listed multiple times. So we have to what's called aggregate the data. So we say, okay, for each LSOA, combine all of those rows together. And this is what we call aggregate in R speak. So we've got the function called aggregate, and we're saying, okay, take the crimes data, and then we're going to, what do we want to aggregate it by? So we're going to say aggregate it by LSOA crimes and the column LSOA 21 CD. So this will group all those together, and then we can do some function with it. So we're just going to say length. So how many crimes are there in each? If we had some data for each crime, if it was, say, a burglary and we had a value of stuff stolen, we could sum the total value of stuff stolen together, and it would give us a total amount of stolen goods in that area. But we're just going to use the number because that's all that makes sense for the data overall. This is quite it's a more intensive process, so it'll take a few seconds to run. You can see it's still working because there's no greater than symbol and the stop sign is out there. Okay, so it's finished now. So it took a little bit of time, but not a huge amount of time. And then if we have a look at this LSOA crimes aggregated, we now have one row for each LSOA. So we have 302, and that matches what our original LSOA was. And it says, okay, so how many crimes are in each area? So the columns have gone a bit skew with, but we've got our code, which is actually now called group 1, and then our number. So how many were in each one? And it's actually counted the rows for each column, which is a bit overkill. But we can tidy this up. So we can get rid of our extra columns. So this code says, okay, just take the first and second column and get rid of everything else. And then if we have a look at the head again, we got our 2 columns, much easier to work with. Rename them to something sensible. So we rename them to LSOA 21 CD, count of crimes, and geometry. There we go. No, that was the wrong one. So we want head, LSOA, crimes aggregated. Yeah, there we go. So count of crimes. So that's how many crimes were reported in that LSOA. And then we can map this now. So we can use QTM to do our simple map. So, you know, this is a fairly unhelpful map because it tells us most crimes were committed in this one, which is the city center. If we do use TM shape, we can get a better classification to actually tell us a bit more. So here we go. So we've got more groups and it's a bit more sensible, but there's still more crimes in the city center than outside it. To a degree, you'd expect that. One other thing that might be more helpful is, okay, what's the crime rate? Because we don't really know how many people live in each of these LSOAs. And, you know, if there are more people living in them, you'd expect the number of crimes to be higher. And so for the rate, we can correct for that. So that's an exercise in the workbook you can have a go at. You know, and the other thing to think about is, okay, so what does this actually tell us? If we see that there are most crimes in the city center, you know, then the crimes don't necessarily happen where people live, you know. So, you know, house burglary probably would, but, you know, some of the other categories, if I can remember my table command, here we go. Yeah, so antisocial behavior arguably could be reported by where people live, maybe not. But things like robbery possibly wouldn't. Shoplifting most definitely wouldn't be. It would be where the shops are, not where people live. Vehicle crime might be at home, might not. So there's all sorts of things we have to think about. The last thing I wanted to mention is how do we export data? So we can save shapefiles from within RStudio. So we have this STWrite function. And so if we do some work in here and want to change it to a different GIS, we can do that. So this will take our LSOA crimes aggregated variable and save it as LSOA crime count as a shapefile. And we can export all sorts of other formats as well using the STWrite function. Hang on, that with the question mark is a help, but we need to do it in the console because it's not going to work otherwise. Here we go. So yeah, it talks about how you can write stuff and you can say different sorts of drivers as well. I think there's a list somewhere, but you can save as a geo package, you can save as all sorts of different formats. Great. So I hope that's helpful, and I hope you enjoyed learning a little bit about using R as a GIS. Please do check out the website and links below. And if you want more information, I'd recommend my book as well.